Hello students, welcome to SHREE SIDDHESWAR Women's College of Engineering Solapur. We are dealing with the unit of functions of complex variables, differential calculus part. So far we have studied the concept of analytic functions, formation of analytic function using different ways or different methods, and harmonic functions. Now we are going to move to the second part of this differential calculus part, that is mapping, or also called as transformation. So let us move to this second part. This is also very important point from exam point of view. There will be surely one question from this topic. So now we are going to see the concept of transformation or mapping. The real function y equal to f of x can be graphically represented by a curve in xy plane. We have seen this, or we have represented functions like equations of line y equal to mx plus c in 10th standard on graph paper. So we know that using graphical method we can find the solution of two simultaneous linear equations in two unknowns. So y equal to f of x can be graphically represented by a curve in xy plane. Similarly, the function z equal to f of xy can be represented by a surface in three-dimensional space. But since the complex function w equal to u plus iv involves four real variables, as w is a function of u and v are also functions of x and y. So here x, y, u and v, these four real variables are involved, and hence we require a four-dimensional space to represent it graphically in Cartesian coordinate system. But geometrically it is not possible. So two planes called z plane and w plane are chosen for the graphical representation of complex function. So here in z plane, a point with x and y coordinates is plotted, and in w plane, a point with corresponding uv coordinates is plotted. Thus, the complex function w equal to f of z defines the correspondence between the points of these two planes. So, for plotting a point, or say w equal to f of z, we require two planes. The first plane is a z plane in which the point z equal to xy, x plus iy, that is z equal to in coordinate pair xy is plotted, and in w plane w equal to uv, this point is plotted. So for representation we require two planes. It means if the z equal to x plus iy describes some curve c in the z plane, then the point w equal to u plus iv will move along a curve c dash in w plane, because to each point xy in z plane there corresponds a point uv in w plane. Thus the function w equal to f of z defines a transformation or mapping of z plane into w plane. So transformation or mapping of z plane into w plane is nothing but the function w equal to f of z. So in this diagram this idea gets very clear. Here in this first graph, this is the z plane, real axis is x axis and this is y axis. This is some region in the z plane. So the points xy are plotted here, and we got this region which is denoted by z. So this is region in z plane. Now w equal to f of z is a function, that is a mapping. So this region is mapped under this function on the region W in W plane. Here real axis is U and imaginary axis is V. So a region in Z plane is mapped onto a region in W plane by the function f of z. So this is the concept of transformation or mapping in case of functions of complex variable. Now we will see a particular case of transformation or mapping which is known as conformal transformation or conformal mapping. Let us consider two curves C1 and C2 in the Z plane which are intersecting each other at the point, say, P point. Let the corresponding curves tau 1 and tau 2 in the W plane intersect each other at some another point P dash under the transformation W equal to f of z. So here in this diagram, this is Z plane and this is obviously W plane. In Z plane there are two curves C1 and C2, and in these two curves there is angle alpha. So to measure the angle between these two curves, we have to find tangents to these two curves at their point of intersection P. Suppose this point of intersection is having the coordinates x0, y0. The tangents, these two tangents are having some angle between them where this angle is alpha. So this is the angle between the two curves C1 and C2 in Z plane. Now observe the corresponding two curves tau 1 and tau 2 in W plane. These two curves are intersecting at the point P dash. Their coordinates of this point P dash are u0, v0. If we measure the angle between these two curves, that is the angle between the tangents to these two curves, if these two angles are same, then we can say that this mapping W equal to f of z is a conformal mapping or conformal transformation. If the angle of intersection at the point P dash in W plane remains constant or remains same as that at the point P in the Z plane, both in magnitude and sense, that is in the direction, then the transformation W equal to f of z is said to be conformal at point P. So for conformal transformation, what is the condition? The angle between the two curves C1 and C2 in Z plane and the angle between the corresponding two curves tau 1 and tau 2 in W plane should be exactly same both in magnitude and direction. Then the transformation W equal to f of z is known as conformal mapping or conformal transformation at this point of intersection P. So this is a particular case of transformation. Now we are going to see some important points from this conformal transformation. There is a theorem: if f of z is analytic and f dash of z is not equal to 0 in a region R of the Z plane, then the transformation W equal to f of z is conformal at all points of R. That is, if f of z is analytic, the corresponding transformation W is conformal. This is only statement is required as per your syllabus. There is no expectation of proving this theorem. Under the conformal transformation W equal to f of z, the lengths of the arcs through P are magnified in the ratio rho is to 1, where rho equal to mod of f dash of z. Thus the infinitesimal length in Z plane is magnified by the factor mod f dash of z in W plane. Next, a point at which f dash of z equal to 0 is called critical point of the transformation W equal to f of z. So these are the statements which we require or we can say that which are important from objective type of question or MCQ type of exam. The conjugate functions u and v means w equal to f of z means it is equal to u plus iv. So the conjugate functions u and v when subjected to conformal transformation remain the conjugate function itself. The tangent to the curve C at P is rotated through an angle phi, which is given by amplitude of f dash of z under the given transformation. So all this is about the conformal transformation. Now we will move to the next point from mapping as per our syllabus, and that is standard transformation. So the first standard transformation we are going to discuss is nothing but the translation. It is given by w equal to z plus c. We know that z is a complex variable, c is a complex constant. So this is nothing but the sum or addition of two complex numbers. So we can add the two complex numbers, means we can add the real parts and we can add the corresponding imaginary parts. So with this we get z plus c, that is w equal to z plus c becomes x plus a is real part and y plus b imaginary part. So this is just addition of two complex numbers, where u is now real part of w means u equal to x plus a and v imaginary part of w means y plus b. So this transformation is mere translation of axis. So from the diagram you will get the clear idea of this, and under this transformation, that is under translation, the shape and the size of the original region in z plane does not get changed, it remains the same. So if originally it is representing a triangle, then under this translation transformation you will get a triangle, but its position will be only changed. There is no change in shape and size of the original region. You may get clear idea of this with these two figures. This is the first one. Here this is the original triangle denoted by triangle ABC. This is the shifted one denoted by the triangle A dash, B dash, C dash. Here the length of the sides, corresponding sides remain same. So these two, we can say that these two triangles are the congruent triangles. Only the position is changed and it is denoted by this arrow. Here x, y becomes x plus 4 y minus 5, because here c is, that is the complex number, complex constant is 4 minus 5y, which is denoted by 4 minus 5 in coordinate pair form and called as component vector. So this is your c, this is c, and hence we get the triangle shifted to some other position, but there is no change in the shape and size of the triangle. One more diagram, one more example. Here the original rectangle is S2, that is denoted by blue color rectangle, and with this arrow this is shifted, S2 is shifted to S dash, and here this shifting is done by this factor translation by 2 plus 3i. This is complex constant c. So c equal to 2 plus 3i is the translation factor. So from these two diagrams it is very clear that under this translation transformation only the position of the region, original region, is changed. There is no change in the shape and size of the original region. Now we will see another standard transformation, and it is rotation. Rotation and magnification. W equal to CZ. So C is a complex constant, Z is a complex variable. So this is nothing but the product of two complex numbers, we can say. So here we are going to use the exponential form of C and Z. So consider Z equal to R e raised to I theta, C, which is complex constant, as P e raised to I alpha, where P and alpha are constants, and their product is W. Call this W as capital R into e raised to I phi. So now with these values of Z, C and W, W equal to CZ becomes R e raised to I phi equal to PR into e raised to I into bracket theta plus alpha. Now comparing LHS and RHS, we get capital R equal to PR and phi equal to theta plus alpha. So in this way it is clear that the original radius is now magnified, and also there is a change in the original angle theta by alpha. So it is called as rotation and magnification. Thus this transformation maps a point in the Z plane, that is PR theta, into a point P dash which is having radius vector as PR and amplitude as theta plus alpha in the W plane. So here the magnification of radius vector of P by the factor, that is modulus of C, and its rotation through an angle alpha, which is amplitude of C, is the result of transformation. So under this rotation and magnification, we get the radius vector magnified and the angle also changed. So this is called as rotation and magnification. This transformation maps the figure in Z plane into the geometrically similar figures in W plane. Let us clear this idea by the diagrammatic representation. Here the original rectangle in blue color is transformed under this rotation transformation to black color triangle. So here rotation is done by pi by 2. So angle of rotation is pi by 2, means alpha equal to pi by 2. This is the second figure. This is the second example. Originally in Z plane, a rectangle with the coordinates or with the vertices, we can say OPQN is given. Under this rotation transformation, it becomes like kite with the vertices O dash, P dash, Q dash, N dash. So this is the concept of rotation and magnification. Now we will see one more standard transformation called as inversion. So inversion is given by W equal to 1 upon Z. Again here we will use the exponential form of complex number. Let Z equal to R e raised to I theta and W equal to R e raised to I phi. So with this inversion we get W equal to 1 upon R e raised to I theta. Comparing LHS and RHS, we get capital R equal to 1 upon R and phi equal to minus theta. So the original angle, if it is positive, then it becomes negative under inversion, and the radius vector also get its reciprocal value under this inversion transformation. Thus, this transformation maps a point P r theta in the Z plane into a point P dash 1 upon R minus theta in the W plane. We can explain this concept of inversion with this diagram. So here P of Z is original point in Z plane its coordinates are r and theta. Here theta is in positive direction, so under inversion we will get theta, that is negative theta, so it will be below x-axis. Here both the planes z plane and w plane are represented only in one diagram, and P1 is nothing but the reflection of this P dash. So this transformation is also called as inversion and reflection. So P dash of W is the inversion of this original P of Z, and P1 is the reflection of P dash. This is inversion and this is reflection. So with this we have completed the concept of mapping transformation, its particular case conformal mapping, and some standard transformations, namely translation, rotation and magnification, inversion and reflection. So try to solve some examples or try to collect some figures where these or such type of transformations you can observe. Till then, have a nice time.